Welcome back, guys. I'm Landers. In today's lesson, we're going to look at an instrument that is very useful in chemistry, and this instrument is called a mass spectrometer. We have a sketch diagram of the mass spectrometer on the chalkboard. Now, what is the use of a mass spectrometer? A mass spectrometer is an instrument that is used to determine the relative atomic mass of elements or compounds. Now, this mass spectrum has a series of parts that are connected, and they are the ones that we use to come up with to identify which atom or which element or which compound is being analyzed. Now, when we are going to look at the mode of operation, we're going to look at the mode of operation in a series of stages. For example, the first stage or the first process begins in the vaporization chamber. What do we use the vaporization chamber for? If the sample which we are analyzing was not gaseous, we first vaporize it in a vaporization chamber. So now, when in the vaporization chamber, after turning this solid to a gas, we then send it to an ionization chamber. Now, what is in the ionization chamber? An ionization chamber has a hot filament that acts as an electron gun. Now, what happens when this filament is heated? When a filament is heated, it produces electrons thermionically. Now, these electrons that are produced, they collide with the gaseous particles of the sample from the vaporization chamber, and they knock off electrons from these gaseous particles, and then they form molecular ions, and these molecular ions formed are positive. Now, the molecular ions are then accelerated into a negative electric field. Because why do we use a negative electric field? Simply because these are positive molecular ions. Now, when these ions are accelerated in a straight line in a magnetic field, they are then led to a magnetic field that deflects now these molecular ions. Now, the extent of deflection depends on the mass to charge ratio. It depends on the ratio of mass to charge ratio. An ion that is heavier is deflected least, and is this one that we are seeing here along this line. Then the lightest ion, of course, that one, when it is light, that one is deflected most, and is the ion we see here. And now these ions fall on the ion collector. When they reach the ion collector, they produce pulses of current. When I say pulses of current, they produce some small current. Some electric current is produced at the ion collector here. Now, when the current is produced here, it is not enough to be detected. In fact, if you might connect our ordinary ammeter in the lab here, you might not notice that current. But what we do, this current is amplified. It is amplified to a sizable amount. Now, after amplifying this current of ours, it is then sent to a detector or a recorder. Now, this record of ours works in a way that it draws on a screen, it draws a graph with peaks that correspond to the various ions that were in the sample. So that is how a mass spectrometer works. Maybe to repeat for you one more time, we are saying that a mass spectrometer is an instrument that is used to determine relative atomic mass of elements, atoms, or compounds. How does it work? Now, we begin with a sample. If the sample of ours is not gaseous, it is first changed into a gaseous state or into a vapor phase in the vaporization chamber. How do you vaporize it? It is heated to see that it changes state to a vapor. Now, when the vapor, when the sample is now a vapor, it comes in the ionization chamber where we have a hot filament or where we have an electron gun. The gaseous molecules collide or are knocked by the fast moving electrons that are produced by this hot tungsten filament that we are calling an electron gun. Now, when these electrons collide with the gaseous particles, they knock off electrons from the gaseous molecules. And now, since the molecules have lost electrons, they form what we call post-molecular ions. And these molecular ions are positive. Now, what we do to the produced molecular ions, we put an electric field, a negative potential or a negative electric field, such that the positive molecular ions, we know that positive molecular ions will always tend to move to a negative field. So these ions are accelerated in a straight line. So this is the acceleration chamber here. If we name it in terms of chambers, this one will be our acceleration chamber. We call this one acceleration chamber. That is the acceleration chamber. Then, when the molecular ions leave the acceleration chamber, we are saying they are deflected. Therefore, the whole of this, where we are having the magnet, is the deflection chamber. Here, this is the deflection chamber. Now, what is happening here? This is the deduction chamber. This is deduction here. Detection or deduction chamber. So, now we are saying when these ions come at a very terrible speed, when they reach the magnetic field, the fact that they are charged particles are always affected by a magnetic field whose direction can be determined using the Fleming left-hand rule. Now, when these particles reach here, of course, they are going to be deflected, but the degree of deflection depends on the mass to charge ratio of the ion that is being deflected. The heavier ions will land this side, then the lighter ions are deflected further. So all these ions are going to fall on the ion collector. So now the number of ions falling on the detector per second, they cause production of an electric current here. But this current is not sufficient enough to be detected by the detector. So what we do, our ion collector is connected to an amplifier. This amplifier of ours, our amplifier steps up this current. It increases the value of current to a sizable current that can be detected by a detector. And now this detector or this recorder draws a graph on a screen. And this graph is what we call the spectrum. It is what we call a spectrum. Now, the graph that is plotted, that is drawn on the screen, has a series of peaks. Now, those peaks on the graphs correspond to the molecular ions that were in this sample. Because what we should know is that when the sample is vaporized and then ionized, it forms the fragments. The fragments that we are making up the sample. So if the fragments are different, it means we are also going to get different peaks being formed on the screen. And now, let's look at the stepwise use of a mass spectrum. Now, we said the first step or the first stage is the vaporization chamber. So we are going to see what happens in each chamber, and when connected, that is the mode of operation. In fact, what we are looking at here is mode of operation, or how it works. So we can say how it works. How it works. Now, how does it work? We are saying that we begin with the vaporization chamber. Now we are going to see what happens in the vaporization chamber. So in the vaporization chamber, we say that if the sample to be analyzed, or if the sample to be studied is not gaseous, it is first turned into a vapor stroke gas. That is what happens in the vaporization chamber. Now, from the vaporization chamber, this sample is sent to the ionization chamber. Now, what happens in the ionization chamber? The ionization chamber consists of the ionization chamber consists of an electron gun. You can say, you can want to call it a hot tungsten filament. Which produces electrons fermionically. The produced electrons, or these electrons collide with the electrons collide with the gaseous sample. They collide with the gaseous sample and knock off electrons from the sample, hence the sample forms the positive molecular ions. That's what happens in the ionization chamber. Now, after the ionization chamber, we go to the acceleration chamber. Let's also see what happens in the acceleration chamber. Now, the acceleration chamber consists of a negative electric field, negative electric field, which accelerates the molecular ions in a straight line. So we have an electric potential there that accelerates the molecular ions in a straight line, to the deflection chamber. The deflection chamber. Now next, our ions are now in the deflection chamber or in the magnetic field. So what happens in the deflection chamber, what we are looking at as magnetic field? What happens in the deflection chamber? Now, while these ions of ours reach the deflection chamber, we said they are deflected depending on the mass to charge ratios. Yes, depending on the mass to charge ratios, these ions are deflected. Now, the ion that has a high